when one of Tomorrow IO's satellite launches, what kind of data are you most excited to get, and what do you do with it?
All right. So, my group is one of the very first groups to see the data from a new satellite. And that part's really fun because it's like, yeah, you get to like open up like a little box and pull out the files and just see like, oh, look, nobody else has seen this before.
That's cool.
Yes. So that also means that I get to look at the satellite data at a fairly low level. So I see some of the initial data products that we produce, which are proxies or like 2 or 3 steps away from the actual raw instrument counts that the sensor is seeing and broadcasting down to the ground. They
Mhm.
go a little bit of calibration from a group upstream of me just to make sure that they're all standardized and that any like obvious biases are corrected for and to make sure that the instrument is working properly.
Yeah.
And then I get that nice view. So I get to view raw satellite radiances. Think of our satellite instruments as cameras in space.
Okay.
Okay, so our eyes also act as cameras. We just see
Mhm.
red, green, and blue. So we have like the different rods and cones in our eyes. For a
Mhm.
satellite, it has something this similar, but instead of seeing red, green, and blue, it's looking at different microwave frequencies.
Okay.
And our satellite can see like 12 different bands of radiation.
That's
So
really
think
cool.
of it like 12 colors.
Yeah, that's
Yeah,
awesome. That's
yeah,
really cool. And then
yeah.
you're interpreting that those
Mhm.
directly from it.
Yeah, definitely. So basically, the low level data, it's incredibly useful. So I work in data assimilation. So I take that data and I also can see what the model should be seeing at about this particular time. And I can link the two up through what's called an observation operator. So it takes model fields and it turns them into observations.
Okay.
So what it does is it takes what the model is predicting in terms of temperature or like surface wind speed or other parameters, and it converts it into something that it thinks that the satellite should be seeing at each of those different channels.
Okay.
Mhm. It also provides the logic to go backwards. So I can take what the satellite is seeing and say, how should I adjust the model?
Oh,
So
interesting.
that's the level at which I'm doing this type of work. And yeah, that's the first thing that I do. I make sure that that is working consistently. And then I refine the science or the algorithm to do that. And then I get to actually run those OSE style experiments that I was mentioning before.
Oh, wow.
Basically, to like do the first set of checks, refine the model a little bit, and
Yeah.
then say, okay, now let's run it over a month and let's see, is it having the impact that we think it would?
Wow. Very cool. And it's very cool that you're like your team just gets to like get the data, the raw, like basically the raw data. You said this is the team that slightly goes in, makes sure there's no major biases or errors, but then you get to go take it and basically you're the one who makes it into models, which is awesome.